Dear students, in this video clip, you will learn how to perform the experiment on solar cell. So this board which you are seeing has 2 meters. The one on the left is the milliammeter, so it's going to measure the current. The one on the right is in millivolts, so it's going to measure the voltage. And along with this, you will have a solar cell panel. Okay, so you can see the cells. Along with that, you will have a light source that's going to work as the artificial sun. Okay, so 3 components we have for this experiment. So let's get started. First is to make the connections. The circuit is again very simple. So at the back side of the solar panel, you will see that 2 points are given, 2 ports are given, black and red. So I have attached 2 cables to it and left them aside. Similarly, we will take a pair of leads, black and red, connected to the milliammeter, and similarly we'll do it for the voltmeter. So now what you see is once you have done these connections, these ends are yet to be connected. So there's a guide on the display board that the red or the positive of the milliammeter has to be connected to this port. The black lead which is attached to the milliammeter will go to this black port. So let's connect the milliammeter. Similarly, let's connect the voltmeter. So the red cable goes to the red port, the black cable goes to the black port, and as you can see on the board, 2 ports for solar cell connection are also given. So let's complete these connections. So red lead coming from the solar cell panel, its back side is connected to the red port, and likewise the black lead will be connected in the black port. So this completes our connection. Now before you start taking the readings, you have to ensure that the solar cell is set properly. So for that, we'll switch on the lamp. In some setups, you may see an intensity knob. Let me just show it to you. So this is a different setup, similar, but here you see this intensity knob is there. We keep it at maximum. So even if your system is not having an intensity knob, it should not bother you. So now once you have switched on the lamp and set the solar cell as close as possible so that the maximum exposure is taking place. And remember that solar cell is a power generating device. So if you have set it properly, you will be able to see the variations on these 2 meters as and when you change the load connected to it. So just like you may have different devices which you can power using AA batteries or AAA batteries. Depending upon how much load you are connecting, the current and the voltage drawn from the batteries would be different. In a similar way, for the solar cell, depending upon how much load is connected, the current and the voltage readings will be different. So here if you look at the knob, for clarity let me just disconnect this. So if you look at this knob, it says load resistance, and as you can see, the knob positions are marked off, that means no load, then 1 kilo ohm, 150 ohms, so on and so forth till SC. This SC stands for short circuit. So over here minimum resistance is applied internally so that maximum current which is possible flows in the circuit. Now as I change the positions of the load resistance, you would see that the voltage and current readings will vary. So here this is what one must take care of. As I'm changing the load resistance, not much variation is seen on the meters. So we have to first fix this. So after adjusting the height and the distance of the solar cell with the light source, now you can see that as the load resistance is varied, the current and the voltage both show fluctuations, and hence it will enable us to take the readings for all the settings.